Good morning, good afternoon, or good evening, depending on where you are in the world, I suppose. And this is the beauty of virtual summits and the virtual dev summit. I'm Malcolm Layton, head of product and co-founder of Fortifyedge. And today we're going to look at a couple of things. One is being advanced neural networks for biometric models, for user identity and human performance. And then we've been fortunate enough to work with Arm and have the preview into the virtual hardware and of the U55. And then we'll go through the TinyMLOps pipeline that we've developed so then we can actually scale our models and take them to our customers. First, it would be great to recognize that part of the work that we do at Fortifyedge, we really want to give back to society and provide a legal identity for all, inclusive, safe and resilient and sustainable AI, and really bind ourselves to that United Nations sustainability and development goals. We believe that this is really important work that they do, and it's fantastic to be able to align what we do to them. And as we go through, I hope you keep that in mind as we go through some of the AI development that we've done that helps provide, protect people's PII, gives them ownership of that as well. We've been very fortunate in our work with Arm and the partnership that we've had, and actually being able to get into the labs and have some time with the folks there. With that has come a capability for us to make a really leap forward, I believe, in on-device intelligence. Taken from what traditionally we know as a smart device in IoT, whether that be a watch or solar panels or anything else with a chip on it, that gives us feedback, but actually now being able to put an algorithm, machine learning or an AI, onto that, and for what we've been able to do is do deep learning algorithms onto the embedded chips. So what do we look like when we do this? So we've moved from smart to on device, and we've actually created this little table for ourselves, and we're sharing it for the first time outside of Arm as well, to actually highlight how we think about models and the intelligence needed at each level. And we go from a smart device there on level 0, where we collect data and send that to be processed. Level 1 is still now you're using advanced neural networks, collecting the sensor information, but I can make an informed decision on the device. And then from that we can inform other devices or humans. Then we go to level 2, and it's actually the human can now be in that loop. And we can start to answer multiple questions with multiple neural networks running. On level 3, we can communicate with other devices and utilize a combined by using sensor fusion to make informed decisions. This is quite advanced, and we'll be looking at that more so next year as some of these new devices come through, and especially when we include TinyML foundation models. How do we adapt to drift? How do we actually build these up and deploy faster, better models? And that Tiny ML foundation works that our team are working on is going to be at the forefront of that. Then we look into the future in 4, and that is looking at the macro environments, taking that environmental awareness and helping the models make informed decisions on the device. So a big consideration for what we're looking at here, this is all on the device. All of this intelligence is on the microcontroller. That's the difference in what we're looking at and what we are doing now and what we'll be doing in the near future. And if it keeps on trajectory that we're currently doing, where we thought 3 years time will be level 3, it is going to be next year. So it's quite exciting for this space, and Arm is at the forefront of that, supplying what we need to actually be able to deploy our models. So we're going to move on to the next section, where we've actually got a little test that we're going to show a demonstration of what sizes we got to on the models, and the Arm embedded evaluation kit that we worked with. The test that we did, we used our Move ID algorithm. That's a continuous authentication or a continuous identification on a Samsung Galaxy 4 watch. You'll see that under the device in the second column there. It runs at 22.5 milliseconds for the inference currently on the watch. Once that's quantized and down at the 50 kilobytes, it improves down to 19.3 milliseconds. Not a huge improvement, but it's a milliseconds, you got to remember. This is two deep learning AI algorithms, an RNN and a CNN, working together to do this work. Now, the speed test that we did for the comparison on it's on virtual hardware. So remember, it's not apples for apples now as far as when we compare the Samsung and then the M55 and U55. These are completely different processors. One was using virtual hardware. So what happened there? This was quite exciting. We've got that again. The M55 runs at 330. We quantized and did some further work with the help from the lab. So thank you and call out to the guys there that helped us with this. We got that down to 50 kilobytes. And who here would have ever thought that people are going to run neural networks, deep learning neural networks at 50 kilobytes? It's just insane. There is no degradation. It works. It's nuts. But anyway, the improvement is huge. Obviously, the size is huge savings there. What we can do and on the chip and with some of the silicon providers and what they're doing, customization and containerization at that level, massive changes are coming to this space very, very quickly. So get prepared. This is what we've done. So if I start that simulation there now, and we'll see what's going on. And this is atop that top corner. It's running at around 18 to 20 seconds for the average inference time. Again, just be aware this is online. So for those that expect it to be down at the milliseconds, we expect it to be as well once we get it working on the silicon, the new silicon with the NPUs. But what we're going to see in a second is that huge change once we swap over, as we're about to now, to the U55, and it plummets. It goes from 19 seconds to 1.4, 1.5, let's say. It is 13 times faster. And if you can't do anything with that, well then, this is just going to be a game changer. That size unto itself is just huge. And we expect a lot of, well, we do know because what we're building now is because of these capabilities. Especially for a swap environment, it's really nicely targeted and fits in that where if you've got size, weight and power that you have to consider, it's going to be huge. But for us at Fortifyedge, so we're going to move to the next part now. So that was, around the M55, U55, the speed tests, how we've got it. The size from 330 kilobytes original down to 50, that's just insane. And then 13 times faster, again. And then with the silicon providers doing the containerization, we can do a whole range of security items and everything else there. Fast, do a whole lot of speed and other items such as power save and everything else, so that we can actually turn things on and off. But to do this, you're going to need to have a continuous delivery pipeline to manage it. If you're going to manage drift, you're going to have to manage it somehow. If you're impacted by size, weight and power, which we are with our customers, I'm going to show you how we handle that, and then also give you a little preview of the platform that we utilized and have developed so then we can actually do this at scale. So when you first will get into this area, you're going to look at IoT devices because they are out in the wild. We actually well beyond the lab now. We've got a lot of devices out in the wild. I really like what Daniel's done here around giving me a stack here, whether that's a IoT from, if I go from devices through to applications. I'm always thinking when we're doing this, oh, what's my communications? Is it LoRaWAN? Is it satellite? Is it Bluetooth, BLE? Is it Wi-Fi? All of these are considerations, not only because of the package loads that you're going to have, but when and how do I actually communicate? Quite important. And then if we go to that left side, what does it look like? What are the jobs that people are doing? You know, what's the business user value proposition for the business at each of these levels? What's the security needed? And when we go to standards and regulations, you know, we've got standards as far as the NIST standards for biometrics. We've got EU privacy laws, and every region has different privacy standards and regulations that you need, and laws that you have to actually make sure that you are covered by. You want to make sure things are secure. You don't want interceptions. You don't want to have anything going on like that around this thing. Part of building those devices and having them run on the edge is the speed and also the security of that. When the AI is working on the device for the device, it kind of gets rid of some of these other steps back up the pipeline. So we'll move on to something else that's coming along is so we're going to show an example of how we do this a little bit in combination with Daniel's work. And I'm going to show you something that Karen's, one of our mentors, has helped us develop. And that's a deep learning, and we're going to use the deep learning AI for a fatigue detection example. So as we consider this, we'll go from the left to the right here. And what we had to do to build out a fatigue detection for edge and cloud devices. Like I said, Dr. Karen Hand from the Australian Deep Learning NLP group put this together for us and with us to actually help us understand and work scientifically, and methodically through each of those stages. So, you know, what's the data? How are we going to get it there? Pre-processing, where's that going to happen? The feature selections, what are those features that I need to build out? The modeling, what type? CNNs, RNNs, NLP, video, who knows what else going on? What's the correct model for the problem that you're trying to solve? And that problem is not just, as we saw in the previous slide, it's not just going to be what that model is going to solve. Your other things that you have to think about is that size, weight, and power. You also have to think about where am I going to put this model in that value chain? Is it just on the device, or am I actually going to use a gateway to run multiple models at multiple places up and down the pipeline? The evaluation of that, how do I validate it? How do I make sure that it works? How do I test those protocols? The deployment, this is where the scalability and what we're going to show you in a second comes in, because there's a lot of management that goes on with deploying AI at the edge. And then once we build all that together, we will then got the detection and we can actually build a fatigue model. Now the team here really did a great job where we, on the watch, we could actually have a user, a test, part of the test team, we could actually test crew, I should say, we actually got nailed that, and we could see the detection of a physiological response to that fatigue that person was under. So it was a fantastic piece of work. And what I really want to show now is the complexity of this environment. Not only do I have to think across the physical world of the devices through to the applications, who's going to use it, the value proposition at each of the stages here in Daniel's work, but then when I'm building my models, I have to consider at what level, if you remember back to the beginning, we were talking about what level the model was. Is it a level 1 model where I just need a single stream, a single question? Do I need multiple questions, multiple answers? Where is this going to sit and how is it going to work? Am I going to work in partnership with another model further up and use sensor fusion to bring them together? So this is why we really do love these two frameworks, and they really help us build out a picture of what's going to happen. And for us, really, and for everyone here, it's nothing but peanut butter and chocolate, really. That's all I can say about these two frameworks and how they work. But what do we want to do when we want to take them? So we've seen this now. Let's take them out into the real world, and we're going to give you a little real world example of where we came from and how we did it when we first started this pipeline. And then I'm going to show you what we've done to build an MLOps pipeline that can actually deploy over the wire to anywhere in the world. You know, we've deployed in Canada, Japan, USA, Europe, and Australia simultaneously whilst doing Blue Force tracking, very sophisticated systems with some of our partners such as Microsoft. So where do we start? This is our, understand the jobs to be done. What is the model for? What are the jobs that the people are doing, whether they're monitoring, whether they're accessing, what's their status? All of these questions are you need to understand. You need to be able to collect the data, and you'll see the photo here. This is one of our first ever deployments. We had to wire the shit out of everything. Welcome to the world of IoT, and where for us, a couple of years ago, we had to actually wire every device to the keyboard, and you'll see up in the background there a little box that all of these red arrows are going to. That's a Microsoft Edge box, which you can take that out. It's ruggedized. You can take that out into the wilderness with you. Holds a little bit of storage and does some wonderful things. Then you got to train the models. So your wearers have to do what's your test protocols, how are we doing that, and your analysis, making sure that those models are correct for the individual. Because remember, now we're talking about individual models being individual devices, and then we're going to be deploy production at scale. That's how we used to do it. It was really good and still a great way to work. If this is where you're at, enjoy it. You'll be here for a while, and it's a fantastic journey to go on. But where have we got to? Well, now and this is again, this is the platform and the example that we're going to see here is for MoveID. It's a continuous authentication and identity for mobile workers. The example that you may see some things that you might not expect, like rifles and so on. That's because this is for a particular example is for first responders. So user is bound to the device, continuous validation from the device. We can see that on the left-hand side, Peter, it's the Samsung that he's wearing, where his position is, so the geolocation, the last on, what device it's bound to at this point in time. Is he in a squad? These things all matter. What is his ID and his model ID? So again, we go to the next, and then there's dynamic attestation. Great information around how do I actually manage these models? How do I manage devices across multiple people? This pipeline is completely automated, so that then we can actually deploy out across wherever you are around the world. But it allows also for our customers to deploy and redeploy as well, and have an audit trail and log. So how do you manage missing devices? You can see here. We know what the device ID is, we know the person, what it is, we know where that position was last time. This might be an off-body event, it might be a lost event, it could be a stolen event, there could be a whole range of different reasons for this. But we can find out what we should do and then what we can do. Really important for bringing this kind of work to scale and out and being able to deploy and redeploy. Through this work, we've been really fortunate. Australian Space Agency we won an award and a grant from the Australian Space Agency for bringing in our TinyMLOps for space. And that's specifically around the problem of astronauts' identity and status. And how do we do that? Well, what we've done is we're starting to build out, and we've started this program, a body of work that we're building out the models now. We will be starting to get the hardware that we need involved. We're talking to all the different agencies that we need to see where we can get this onto the International Space Station, which is our ultimate prize. Using those deep learning models and updating them, giving environmental factors. We're very lucky here in Hobart, where we've got a hyperbaric chamber and access to that, where we can do testing with environmental factors. Unfortunately, or fortunately for the test subjects, we're not allowed to radiate them, but that hyperbaric chamber has everything else that we need to create the synthetic data ready to be deployed, that model up into the ISS. So as well, looking at the fatigue then, not just the physiological response, but also the cognitive response as well. And we've got some clinicians and some academics working with us on that as well. So we're very fortunate that we've got some great support and partners to help us with this. And again, with the advent of the U55 and the IP that Arm and their partners in the silicon are providing, you can now see why these kinds of speeds are really important. Because in space, there's no spare batteries. You can't go outside and do a whole range of different things. It's the extreme swap environment. Once we've done this, so what are we doing it for? Well, it's to keep humans safe. It really is around the identity, status, and safety of an astronaut. How do we know they are who they say they are? What's the status of that astronaut? And then, are they safe to proceed with the job that they need to be doing? Now, this is true for mining. It's true for Industry 4.0, manufacturing. There is a lot of industry that this, first responders, nurses, doctors, we can go on for a long time, where the identity of an individual is paramount to know, continuous authentication, where the PII remains on the device. Their status, are they okay? And then, are they safe to proceed with the job at hand? This is really important steps for us. We currently do identity and status, and then we're putting this into space with the MLOps pipeline. The beauty of this, and we come full circle now, is you are the password. And we've ended up being able to create a personal living digital twin that seamlessly controls access to your digital life. And all the while, we've been considering through this whole pipeline the United Nations and looking at that justice for all. How do I actually give the individual, which is seen here through my own personal living digital twin, access to themselves and their own data? I am me and I am my password. Really important when you think of emerging markets such as Africa. How do we protect those that need protecting with their data? How do we make sustainable cities and communities safe? And how do we have that next level of industry and infrastructure there, critical infrastructure there, that's also safe and ready for us as we move forward? What's next? We're looking for POCs with enterprise customers, OEMs. And then really, if you're interested in anything that you've seen, please reach out. Contact us at fortifyedge.com. I would really love to thank Arm Mary, Tobias, and the crew in the UK in the labs that actually helped us develop a lot of these things and really pushed our understanding what is possible and dream big. I hope you've enjoyed what you've seen tonight, today or this morning, and I look forward to your questions in the coming moments. Thank you very much.